Hi everyone, welcome back to my YouTube channel, Chemistry with Sumitpramar. Today we'll be solving past paper from year 2018, October-November series, paper code 970111. Let's look at question number 11. Two reactions are shown. Reaction 1, nitrogen gas reacts with hydrogen gas to form ammonia gas. In this reaction, finely powdered iron catalyst, that means iron solid catalyst, is used. Reaction 2, ozone gas is converting into oxygen gas and the catalyst used is vaporized tetrachloromethane, that means CCl4 gas. What kind of reaction is this? As we know that if the catalyst state of catalyst and the physical state of reactant and product are same, it is called homogeneous catalyst. And if the state of catalyst is different from the physical state of reactant and product, it is called heterogeneous. In reaction 1, the physical state of catalyst is solid, whereas the physical state of reactant and product is gas, hence it is a heterogeneous catalyst. In reaction 2, the catalyst used is CCl4 gas, which is same as the physical state of reactant and product, hence it is homogeneous catalyst. Hence option. Question number 12 says sodium and sulfur are burnt separately in oxygen. Each reaction has a distinctive color flame. As we know that sodium burns with yellow flame and sulfur burns with blue flame, hence option C should be the correct response. Let's look at question number 13. X and Y are elements in period 3 of the periodic table. Let's look at the elements in period 3. Period 3 elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The first statement says that the oxide of X is solid at room temperature and has a giant structure. Oxides. For sodium it will be Na2O, magnesium oxide MgO, Al2O3, SiO2, P4O10, SO2, Cl2O7, and argon is a noble gas. Sodium oxide is solid and has a giant structure. Magnesium oxide is also solid and has a giant structure. Al2O3 is also solid and has a giant structure. Similarly for silicon oxide. All of these are solid and has a giant structure. These have simple molecular structure, so they cannot be X. X can be sodium, magnesium, aluminium, or silicon. Let's look at the second statement, which says the chloride of X does not react with water. Chlorides. For sodium it will be NaCl, for magnesium MgCl2, aluminium is AlCl3, and this is SiCl4. Among all of these four, we know that sodium chloride and magnesium chloride dissolve in water and they don't react, whereas AlCl3 and SiCl4 they react. Hence the X can be either sodium or magnesium. Now let's look at the third statement. Third statement says that the melting point of Y is argon is the only element in period 3 with a lower melting point than Y. If I look at the trend in melting point, we know that among metals sodium will have the lowest melting point, and then higher will be magnesium. Above it there will be aluminium. Silicon will have the highest melting point and the melting point decreases. Phosphorus has lower melting point. Similarly for sulfur, sulfur is also lower melting point. Chlorine is a gas and argon has the lowest melting point. So we can see that above argon there is chlorine. Chlorine has melting point just higher than argon, so Y is chlorine. So the required answer will be, if I form a formula, it can be either magnesium chloride or sodium chloride. So from the options we can see that option C is the correct response. Question number 14 says, which row describes the structure and bonding of silicon dioxide and silicon tetrachloride? If I draw the structure of silicon dioxide, silicon forms four bonds with oxygen atoms. Use black color for oxygen. These oxygen atoms can further form bonds with four silicon atoms, and these bonds can continue to extend to form giant covalent structure. That means in silicon dioxide we have covalent bond and it's a giant structure. If I look at the structure of silicon tetrachloride, silicon can form bond with four chlorine atoms, but these chlorine atoms cannot form bond with any other silicon atom because they can form bond with only one atom. Hence they have simple molecular structure and they have covalent bonding. Hence, let's look at question number 15. A sample of anhydrous calcium nitrate is placed in a test tube and heated in a roaring Bunsen flame until it decomposes. The description of the gas in the test tube is then noted. A glowing splint is then put into the test tube and any changes are noted. If we heat calcium nitrate CaNO3 hold twice at high temperature, it breaks down into calcium oxide, NO2, nitrogen dioxide and oxygen. We can balance it. The color of the nitrogen dioxide is brown, and we know that oxygen gas can relight the glowing splint. Hence, thank you for watching my video. Please like, share and subscribe to my channel, Chemistry with Sumit Pramar.